Today arrived a new JLC PCB package, and this hopefully gets me from this early prototype to finally this type of PCB that I can put into my DoorTag customizable smart sign, which looks like this, to display our Microsoft Teams status and more. So let's see if that version finally works. So these are already partly pre-assembled to avoid getting the hassle with all of the SMD components like resistors or capacitors. So I only have to solder a few chips like the TP and some voltage regulators. So we will see that in a moment as well. Okay, perfect. As you can see, the layout looks a little bit different because I want to minimize the space for getting the holder, the door holder and so on to work. And as you can see, also the main MCU is missing, so we will solder that as well, and as mentioned, some other small components. And I can always recommend to have some testing pins like these on the board, or as you can see, probably these, to be able to debug, because I can guarantee you there's always something not working as expected. For example, my latest mistake was regarding the voltage divider to have that wire to a wrong pin. Accidents like this happen all the time, and they can be a little bit easier debugged by having test pins and also rewiring, of course, if something happens. So just as an example, in that version, I also had a misconfigured pin, as I mentioned, with the voltage divider. So I just quickly soldered it a little bit different. And yep, with a few test points, that would have been easier probably. But here I was lucky to actually use the resistor. So yeah, just one learning that I made. Always have some test pins available. So that's the current version. Let's solder the other stuff and then let's see if it works or not. Here you can see me desoldering an old NIF chip because I forgot to order some new ones. So I had to salvage an old one from an old PCB prototype. But in the end, it had a great turnaround. So here you can see me soldering and heating up the pads, and after that I will continue with the main CPU. Sometimes I first heat them up on the heat plate so that they not cool down all of the applied solder paste. But in the end, I'm still sometimes struggling with applying all of the components. I'm not sure why it looks so flawlessly when other YouTubers do it. Maybe you can give me some tips in the comments, so I would appreciate them. Of course, here I tried to lower the airflow, but I still managed to flip over the chip itself. So I don't know why this happens so often to me. Yeah, but in the end, I'm quite happy, and soldering here is just, let's say, one step for producing it with a machine, or let it produce, for example, by JLC PCB in full with all of the parts assembled. But I had a lot of parts from prototyping, so that's why I chose to just go with manual solder for the special parts. And it's also cheaper to produce some prototypes, because when you are using different chips that are not, let's say, standard or basic chips, you pay, I think it was $3 or €3 extra for each different component that is not basic. So if you sum it up here, I think, what was it, 4 or 5 different chips would end up with $15 extra for just prototyping. And I thought, okay, I need around 5 minutes to solder them, so shouldn't be that big of a deal, and I save some cash on the way. Then I noticed that I had mistakenly shifted the MCU, the NRF. So here you can see me moving it a little bit more in place, that everything fits as expected and matches all of the pads. After that, I usually apply some more solder paste where I noticed that it's too less and there may not be a good connection to the chip. And yeah, just helps me to reduce some unexpected bugs that I had previously as well. So always make sure that all of the connections are quite good, so you avoid spending a lot of time debugging something that you think is code, for example. Okay, so this is the part where it gets interesting. This is my flashing setup, a Nordic dev board with some wire clamps. Now let's just connect it and hope it does not make the magic smoke. So I'm not entirely sure if the pin configuration is still correct. Okay. We got at least some lights because that's the already flashed chip. Oh, and we got a working display first time. So I did a major redesign of this board. Damn. I thought it would start with a depression session, but this is amazing. So this is my 10th version of the board, and I'm quite happy that it works first try. So this is amazing. So it works. Now the next thing that I need to check is to validate the charging board via USB-C, and then from this prototype, the wrongly set up and wrongly configured voltage divider to measure the battery voltage. Yeah, I think let's switch to the UART session and try to read out the voltage of the battery in a moment. Okay, let's check the UART, and we already got a battery voltage of around 3 volts, so 2987 millivolts. So now it's 3 volts basically. So that's already promising, because I think SWIDO works with 3 volts. So that looks already good. But let's try it out with the power bench supply to actually get some different values, hopefully. So, of course, I forgot to solder down the battery connector for testing, so I did that. But we don't even need it, because we want to use the bench power supply to have a variable voltage to test everything. So I have here a spare part of the male connector, so I will connect that and then to my bench power supply, which I have already here. So I'm not sure if you can see that. That one as well. So, and just to be sure, okay, what did I do? I hope I did not create a short in here. Good. Still looks like it's working. Let's disconnect the power of the SWIO. So disconnect power. So only grounding is there, that's fine. And yeah, let's power it up via the bench supply. Just make sure that it's off. Okay, bench power supply is 3.3 volts. And let's check if we turn it on, if it's still working. Okay, that looks good. LED is still blinking. And let's check the UART. So it's initializing, as you can see here. Let's wait for the battery reading. Should be 3.3, hopefully. That looks really good. It's 3.3. Let's switch a little bit the voltage. So on my bench power supply, I will increase it now to, let's say, 3.6 volts for now. Let's wait for the reading. Perfect. And now let's change to 4.2 volts, because that's the maximum battery capacity. or the maximum battery voltage that we have while charging. And that's also really good. So I like that result a lot. So far the PCB is promising. And yeah, okay, yeah, so one small thing regarding voltage divider. So I have my voltage divider with 2 mega ohms and 510 kilo ohms. I think usually when you design a voltage divider for some load circuits, you have it all the way around when you start working with voltage dividers. So you can actually calculate it with a lot of different websites. So for example, I have 510 kilo ohms in the top. So that was the value I started with, and 2 mega ohms at the bottom. And if we have a fully charged battery, we have 4.2 volts. So at the voltage divider, we get around 3.3 volts, which is kind of fine for the chip itself because the chip is driven also with 3.3 volts. And the datasheet tells us that you cannot drive the external pin, for example, the ADC pin, with a higher voltage than the actual chip is driven. So that's why we have that voltage divider. So the voltage divider basically protects the chip itself because we cannot have a higher voltage than the chip is driven with. So that's how you usually do it. But then I also have a gain setting in my chip. So in that case, the NR54L15 supports a gain of 1 to the times of 4, which means I have a maximum voltage 4 times of the internal reference voltage. And the internal reference voltage would be, for example, if you take a look at the calculator, 0.6 times 4. So because 0.6 volts is the internal reference and times 4 for the gain multiplier, I can read actually a maximum of 2.4 volts. So that's why I switched the voltage divider so that I have the 2 mega ohms at the top and the 510 kilo ohms at the bottom. And then we get around 0.85 volts. So that's basically how you can do it as well. And if you have a lower charged battery at, let's say, 3 volts, we have 0.6 volts, or if we take 3.3, we have around 0.67 volts. So that's the maximum voltage our ADC can actually read. So 2.4 volts. That's why I switched it the other way around to make it even smaller. So then we have a physical secure barrier with the actual voltage divider, and we are also fine for the internal reference together with the gain of 4. But then after looking again at the data sheet, I actually noticed that the internal reference voltage is 0.9 volts. So not 0.6. In that case, we could calculate 0.9 times 4, which is also 3.6 volts. So that would be actually fine to use it also the other way around. So I actually didn't need to change that, but I think that would be fine. So please let me know in the comments what you think, which orientation the resistor should have and if it makes a difference or not. So let's see what our voltage divider outputs. So currently 0, and let's measure. Can you see that? No, you can't. Oh. Okay, it's still visible. So let's measure 1 to ground. I have, as mentioned, the testing pins, always useful. And then our voltage divider, which is directly here at the capacitor. And we get around 0.82. So that looks really good. Same as we calculated, almost the same. I think the voltage divider calculated at 8.5 if I'm not wrong. 0.85 I mean. And that looks good. So I'm not sure how accurate the bench power supply is, of course. So that's really good. So, and if I put it down to, let's say, 3.2 volts, which is on the lower end, I get around 0.6 volts. So that's fine because The ADC reading itself is pretty accurate. So we have just a span of around 0.3 volts, let's say, from maximum charge battery to discharge battery. But yeah, the accuracy is quite good. So this is still good enough for us. That's it. I'm quite happy that it works. Let's just try out one more time the switch here, the physical switch, because I see some ghosting here in the right corner. That's usually when there's some problem with the voltage. So let's try again. And hopefully we have a good result. Okay, it does the LED testing. Now it should be updating. Oh, that does not look good. I'm not quite happy about that result. So let's see how we can fix that. Okay, so I just reconnect the display itself, because sometimes I have the feeling that different power supplies, sometimes if I switch between SVDIO and my bench power supply, the ePaper display is quite tricky sometimes to get it right, but I think it's now working again. So that looks really good. So the next part is to put it into the new frame. Currently I am having this one as my prototype, which is milled aluminium, but the frame design changed a little bit, so I will put it into the new one that I 3D printed, and let's see if everything fits together. Okay, now I have switched off my bench power supply. Now let's put it into the frames. So I have here my new prototype 3D printed. Unplug where the battery connector is. And now I just have to place it in the frame. Then I have here a plate in the middle. Which also fits in. Now the moment is if the PCB fits inside of the 3D printed middle place. That's always a little bit tricky. But looks good. So I just need to push down a little bit. Actually, damn, I forgot. So this is the issue that I forgot with the new PCB design, but it's luckily just a minor detail I missed. Just that you know what I mean is. So this is my old prototype PCB, which has these two edges here. And I forgot in the redesign to put it in here as well. So on the left side, it's still there. On the right side, I forgot it. So I need to cut it off manually. Shouldn't be a problem, hopefully. But let's see. Okay, I think that looks decent. Let's try to fit it in. Okay, I'm quite happy with that fit. May need to file down a little bit the USB-C connector here, but overall I'm quite happy. So that prototype is working. Let's see if the connector is still working, because I did some changes there as well and I'm not sure if it fits now. Maybe it's easier to plug in the display first and then put the PCB inside the frame. Okay, I got some little flex there, so it's not perfectly fitting. So here the connector is a little bit tight, but I think for prototype that's still good enough. So that's it for this part. Let's connect the battery. Let's make sure it is turned off first. So this is not the original battery in the end. So this is just another one for prototyping. And also I think this connector is not the final one because it's still a little bit big. So I may need to change it, I think. That's that part, and now the interesting part is if the backplate will fit. So probably not, because that's usually how it how it went with my prototypes. Still a little bit too much cable in here, but let's ignore it for now. That can be fixed later. So, okay, at least the LED is correct, but I think it's, no, okay, it fits, maybe a little bit too tight there. So I still have the, no, okay, perfect. Damn, that looks really good. Let's screw it down. As mentioned, there's still a little bit of work to do, but I'm quite happy with the intermediate result, let's say. So I have some tiny screws for the back, and yeah, let's screw it down. Okay, perfect. So that's the final result. I'm quite happy. So of course, it's not a good finish, but from functionality point of view, I think that's quite nice. So here we have the indicator LEDs, here we have charging LEDs, and here we have the power switch. So it's a little bit too small. I have also large ones. I don't know why I soldered on the shorter one, but yeah, for prototyping, I think that's still okay. So let me get something small so I can turn it on, maybe the file. So let's see if it blinks. Perfect, perfect. Okay, it's doing the test LEDs, and now it should update the display. Perfect. So I'm quite happy with the results. The only thing that is left now is testing the USB-C charger. So let me get a cable. So let's see what happens if we plug it in. Perfect. We get a red light. And if it's full, we should get a blue one or a green one. What was it? I think it was a green one. So yeah, that's it. I'm really happy with the result. So thanks for watching, and we will see us in another video.